Hello students. So today let us see how to find the molar conductance of an electrolyte at infinite dilution. So we are taking this type of examples. See the first example. At 25 degrees Celsius, the molar conductances at infinite dilution for the strong electrolytes sodium hydroxide, sodium chloride and barium chloride are given here. Three values are given in Simon meter square per mole. So we need to calculate lambda m naught, that is molar conductance at infinite dilution for barium hydroxide. Okay. So here what you can do is simply you can see what are the ions present in barium hydroxide. That is, if you take BaOH twice, here you have one barium 2 plus ion and two OH minus ions. Okay, so now we need to get this particular species from the given species, that is NaOH, NaCl and BaCl2. Okay, so how can we obtain this using these three? See, we need barium ion. So barium ion comes from BaCl2. So I'll take BaCl2. Then I need two OH minus ions. So I need to add NaOH and I need two OH minus, right? So I'll take two NaOH. Okay. See, from these two now you will get Ba2 plus ion and two OH minus ions. But you have something extra also. That is two chloride ions you have extra and you have two sodium ions extra. So you need to just remove them, means subtract 2 NaCl. This is how you are doing it. Okay, so this simple equation will give you barium hydroxide. So the same thing we are doing with the values also. So you take the values now. Barium chloride. See, look at the values properly. It is given respectively. So barium chloride value is this one, third one. So we have to take 280 into 10 power minus 4 plus NaOH, that's the first value. So 2 into 248 into 10 power minus 4. So this is the second value. Then minus 2 NaCl. So I have to take 2 into 126 into 10 power minus 4. So like this you can write it very easily, and now you can solve this. So when you solve, you will actually get 524 into 10 power minus 4 Siemens meter square per mole. So in the same unit, you will get the answer. So here, whenever you have any particular electrolyte, you have to look at the number of ions. So you should be careful with these numbers. If you just do BaCl2 plus NaOH minus NaCl, you will not get the right answer. Okay. So this is the first example we have seen. Now let us take one more example. See here. At infinite dilution, the molar conductances of CH3COONA, HCl and CH3COOH, these three are given. Now in Siemens centimeter square per mole, the molar conductance of NaCl is asked at infinite dilution. So again, same thing we have to do. So we need NaCl now. So how do we get NaCl from the given species? So we need Na plus ion and Cl minus ion. So I can get Na plus ion from CH3COONA and I can get Cl minus ion from HCl. So I am adding these two. So now NaCl is there and also there is something extra, that is CH3COOH. So you have to subtract CH3COOH. Okay. So here it is single Na plus and single Cl minus. So there is no multiplication of any number. It is straight away you are taking all these values. So take the values accordingly. So you have 91 here, and for HCl it is 426. Then minus you have to take 391. So you will get the answer 126 Simon centimeter square per mole. Okay. So this is how we solve this type of questions very easily just by this particular logic. And here molar conductance is asked. If equivalent conductances are given and equivalent conductance is asked, then also you are doing it in the same way. Okay, so same addition and subtraction of ions you are doing. But only thing is, here we took number also, right? How many ions were there? Say 2 OH minus, so we took 2 NaOH. So if equivalent conductance is asked, you are not taking this 2. Okay, directly you are doing BaCl2 plus NaOH minus NaCl you are doing. If equivalent conductance is asked, that's the only difference. So I hope it is clear for all. Thank you so much.